Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 9 from the Murach MySQL book, second edition. And Chapter 9 is entitled How to Use Functions. So I'm going to leave you to read about the objectives on your own here. And then we come to a sort of an overview of the various functions that we're going to be learning about. Okay, and these are some of the functions that are used to manipulate the values of strings. Okay, and here on slide number 4 are some more. And let's get looking here on slide 5 with some string function examples. So one that we've already seen, but maybe we haven't seen every little part of, is concat. So concat is a way to concatenate strings. So we say a concat, and we've got two substrings, last and first, and we get last first. Okay? And it might not be obvious from the example here, but we're not limited to only two strings or expressions. So we can concatenate, for instance, a last name, a first name, a middle initial, all in one expression. And maybe we can put some spaces and some punctuation in there too. Okay? The next one, concat underscore WS, is for concat with separator. Okay? And here, this is for the classic case where you want to concatenate a list of things and you want to separate them. Okay? So here, the first argument, as I like to say, is a comma space string, then last, then first. And since we only have last and first, we've only got one separated by string. But again, we're not limited to two, we're not limited here to three arguments. So we could have a whole long list of, say, column names that we wanted to concatenate, and we wanted them comma separated like this, and we could do it with concat WS. Okay, then we've got trim. We've got L trim to trim from the left side. We have R trim to trim from the right side. We've got trim that can trim from both sides. Now, as you can see from the result over on the right side, the default is that we're trimming spaces. Okay, so the easiest things with trim and L trim and R trim is we're trimming either leading or trailing spaces or both. Okay, a trim is more flexible than that. So you can say trim, and then here we say both, and we're going to trim asterisks from a string that has leading and trailing asterisks, and you can see we're trimming both sides for asterisks. So that's pretty flexible stuff. We can use lower to set text into lowercase. We can use upper to do the opposite. We can use left in order to get the left substring of a a column, or in this case, a literal string. And we can use a right to get the right substring. Okay? Now, you will notice here that all of these string expressions are using a single quote and apostrophe. And the way that we have MySQL configured, it will accept either apostrophes or double quotes. Okay? But that's not true of all SQL products. So this approach that we're taking here is a good conservative approach, just using the single quoted strings. Okay, so here's some more. Substring and substring index. Okay, so we're saying that we want to take, first of all, we have the string that we want to work on, and then we've got 7, and then we've got 8. So we are taking 8 characters starting in position 7. Okay? So this is 1, 2, 3, 4, 5, 6, 7. So we're starting with the 5, and we're going all the way through to the end of the 2. Just what we want. Okay, now pretty cool is this substring index. Substring index works on dividing a string on the basis of a character that's being used as a delimiter. So the first argument is the string that we're going to work on, and that could be a column, or it could be just a literal string, or perhaps an expression. The second argument is the separator expression. Okay. The third argument says how many of these we're going to count until we stop taking characters. So if we say -2, it says we start from the right side and we go backwards until we get to the second one, and we stop right before we get to the second one. So we take MOC dot HCARUM, see the second delimiter and say, oh, we don't want that, but we want everything before that. And we know we're going backwards because this is a negative. Okay? So kind of tricky, but kind of expressive too. Length of MySQL 5. Length of MySQL with some padding. I guess 2 spaces on the front, 2 spaces on the back. 9. Oh, okay. Now you should know that length is affected by multi-byte Unicode characters. We're okay when we're using the normal alphabet because all of the normal alphabetics, A through Z, lower and uppercase, are represented in UTF-8, which is the encoding that we're using. They're all represented by a single byte. Okay? But there is another function, char length, that will be useful for finding out the length in characters of strings that might have multi-byte characters in them. So this might be true in UTF-8 if we were using some languages characters from not from the typical English American alphabetic character set. We can use locate in order to find a substring. So we want to locate SQL and space MySQL, and it's telling us that it starts in position 5. And we say we want to locate the dash in 559.555-1212, and it says it starts in position 10. Okay, so we have the next one is a combination of two functions, and this is why I think it's important to do the practice exercises. You'll recall that the exercises we're doing for the class are the My Guitar Shop exercises, so they're not the ones that are in the book. But the ones that are in the book, we have the solutions to them. You just have to look them up in the code that we downloaded. And you may want to look through those as a way of just getting a handle on things like this replace, write, blah, 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 blah. Because we are replacing parts of a string here. So this is kind of complex. We are here, we are inserting some text. And apologize for the ringing phone. So we are inserting MySQL into the string. And in the second one, I'm sorry, we're in the first one we're inserting Murachs, and in the second one we're inserting Murachs, and we're doing one with double quotes and the other with single quotes. And of course, when we use the single quotes, that means we have to use two single quotes in a row to get a true apostrophe. Okay, so let's look at these a little closer. All right. So here's a select statement that uses three functions. Okay, it uses concat with separator. Okay. It uses right, and it uses left. So we want to concat with separator vendor contact last name, vendor contact first name. Okay, and the separator is going to be comma space. So that's why when you see in the results set, you'll see we have last name, comma space, first name. So that seems to be working fine. We want the eight rightmost characters of vendor phone. So it looks like we're getting that. So we're chopping off the area code. And then the where clause is looking at the left, the four leftmost characters of vendor phone. So it has it begins with a left paren, and then 559 is the area code. Okay. How to sort by a string column that contains numbers. Okay, so here's the problem to be solved. If you look at this simple select where we are ordering by employee ID, okay, and let's assume that employee ID is a string here, okay. So how do strings collate? Well, 1 comes before 17, comes before 2, comes before 20, comes before 3. oh, that's ugly. Typically, when we see numbers like this, we expect them to be sorted more like numeric values would be sorted. Well, how can we fix this? Well, we can say we want to cast emp ID as signed. So that's going to cast it as a signed integer. Okay, and so it is going to put it in the order as though it were a signed integer. So now we've got 1, 2, 3, 17, 20. It's exactly what we want. And we had learned the cast before, so not too surprising. What else could we do? Well, there's another trick, okay, and we see it here on slide 10. We could put emp ID, which is a string, into an arithmetic expression, and MySQL will convert the string to an int in order to try to add it to the number 0, and we'll get the same effect as we got with the cast. Now, which would be better documentation? I think the slide 9 is probably better documentation than slide 10, but they both work. Okay? Or we might use lpad. Okay? What does lpad mean? It means, well, to pad a string on the left. Okay? So we say lpad emp ID 2, 0. Okay? And what's happening? Well, the short employee IDs are being padded with leading zeros, so that instead of just having 1, we have 01, we have 02, we have 03. And this solves the order problem as well, although we might not be thinking of the employee ID in these terms. Okay, so see how that goes. Okay, so how to use the substring index function to parse a string. All right. So we are saying here that we want to use, we want the substring index. So we want to start at 1. Okay. And then we want to, we want to take the string up until we get to the first occurrence of space. Okay, so that's going to be the first name. Okay. Now the second one has the same kind of approach, but because we say -1, we say we want to go from the back end, and we want to stop at the first occurrence of space. Okay? Now, I just want to point out that this works well in the result set for all but the last case, because Alicia von Strump probably thinks that her last name is von Strump. Okay? And our code is saying that her last name is Strump. So not perfect, but a start. Now, this is why we would like to, when we design our database, we would like to have our data as disaggregated as possible. Even though we think we might always be taking a name and expressing it the same way. first name, middle initial, last name. Okay? We might eventually not want to do that. We might want to say uh, last name, comma, first name, uh, space, middle initial, period. Okay? We might want to do something like that. If you have stored the name as just one column, you're left with this fooling around to try to disaggregate it. Okay? It's easier to aggregate things with concat than to disaggregate things like this. So the lesson here on slide 12 is that when we designed our database, we would prefer to not just have an emp name column. We would like to have columns for the components, either last name and first name, or last name, first name, middle initial, perhaps last name, first name, middle initial, last name, suffix, all those kinds of things. And then when we need the name all together, we'll concat it together. And when we need the parts, we don't have to do sleuthing around like this code in order to get the parts and get the result like we did in the last line in the result set where we didn't get it right. We said her last name was Strump instead of von Strump. Okay, how to use the locate function to find a character in a string. So the first one, we're going to use locate space employee name as first space. Okay. And then we say we want to locate space employee name, locate space employee name plus 1. So we're looking for the second space. Okay. So locate space employee name is going to bring back a number. Okay. And we can use that, we can nest a locate inside of a locate in order to locate the next one. Okay? It's this kind of thinking that sort of eludes those kind of new to programming, right? It's sort of indirect. You kind of wish that you had a way to express this that was more direct, less kind of horsing around. But as you see, sometimes you have to resort to horsing around. How to use the substring function to parse a string. So we've got a substring 1 employee name locate space employee name -1. So what we're essentially saying is that we want to pick out the last name. Oh, sorry. We're picking out the first name, and then we're picking out the last name. Okay? So we're using a combination of substring and locate. Now, I just want to point out that we're only left to this kind of horsing around because we've made the, I think, pretty serious mistake of defining the database such that the employee name is in a single combined column. Okay, so if you look at the expression here, it does solve the problem in getting Alicia von Strump correct. Okay? But in my mind, this is a lot of work to solve a problem that you shouldn't have had to begin with. Which doesn't mean that you don't need to come up with the right answer to the exercise, but I'm just saying. Let's look at the numeric functions a bit. So the ones that we're we're highlighting here: round, truncate, ceiling, floor, absolute value, sign, square root, power, rand. Okay, so let's look at round. If we say round and then the second argument is a 0, then we don't allow any decimal digits. We're doing the same thing on the next one. Okay? But we get rounding. Okay? So 12.49 is going to round down to 12. 12.50 is going to round up to 13. That's why we got 12 on one and 13 on the other. Round 12.49, one decimal digit is going to round to 12.5. Truncates the number, so there's no rounding going on at all. So we're going to get rid of the extra decimal digits. So if we truncate and the second argument is a 0, then we'll get rid of the decimal digits without the benefit of having rounded. And likewise, if we truncate with one decimal digits, you can see that 12.49 truncates to 12.4, even though it would have rounded to 12.5. Ceiling. Okay, so ceiling of 12.5 is 13, so it's the next higher whole number. Ceiling of negative 12.5 is 12, so it's still the next higher whole number. It doesn't go farther to the negative, it goes farther to the positive in the same way. The floor of negative 12.5 is 13, negative 13. The floor of 12.5 is 12. So the ceilings are going on the right side, the floors are going on the left side. And it just has to, you can kind of think of that as the right and the left side in terms of the direction on the number line. The abs will bring you absolute value. So absolute value of negative 1.25 and 1.25 are both 1.25. A sine of negative 1.25 is minus 1. Sine of 1.25 is 1. Okay. Square root will give us the square root. Power will do exponentiation. So if we want to square 9, we say power 9 comma 2. Okay, that'll give us 81. Okay, if we said power 2 comma 2, that would give us 4. If we said power 2 comma 3, that would give us 8. A rand will give us a random fraction between 0 and 1. If we need a random number on some other scale, we're going to have to put that in an expression where we do some multiplication and maybe a little addition as well. So here on slide 17, we're showing that sometimes when we have floating point numbers, their value is rounded and approximated. And this is a problem when we are trying to search for values. We may be searching for the real value without the rounding, but it's possible that there might be other rows that we would like to match where they rounded. So here on slide 17, when we do where float value equal 1, we're only getting a match on row 2, which is, and which is exactly equal. And sometimes that's a problem. So how to search for approximate values? Okay, well, we could do this. We could use between. So we could say where float value between 0.99 and 1.01, we could say what our acceptable level of error is. And then we're matching 3 rows. Or we could say where round float value 2, so we're going to round it to 2 decimal digits equals 1.00. So those are 2 different ways to uh, offset the problem that it's hard to search for exact floating point values. Now we've got functions that get the current date and time. So we've got now, sysdate, the current timestamp. We've got cur date and current date. We've got cur time and current time. We've got UTC date and UTC time. So let's look at what we get for various things. For now, we get the current date and the current time. For sysdate, we get the same. We get both date and time. For cur date, we already discovered a chapter or so ago. We get the date, but we don't get the time. For cur time, we get the time, but we don't get the date. If we say UTC date, we get the date, and at in Greenwich Mean Time, if we do UTC time, we get the time in a 24-hour clock at the 0 meridian in Greenwich. The current timestamp, we get the date and the time, and then the current date and the current time are going to behave like cur date and cur time. Now, there are date and time parsing functions to help you get the comparison that you want on one hand, or to print or to display exactly the expression that you would like. So we've got a day of month, year, hour, minute, second, day of week, quarter, day of year, week, last day, day name, month name. So that looks appealing. So let's look at this. We've got a lot of examples here on slide number 22. So day of month of September 3rd turns out to be 3. Month for the same date is 9. Year 2014-09-03. I believe that's a typo. Okay, so I think we changed the slides from 2011 to 2014, and we forgot to fix the second column. Okay, so there's no funny thing about the function here. We just have a typo. The hour is going to take the hour part, the minutes part, the second part. The day of week is going to tell you what day of the week it is. Okay. The quarter is going to say which quarter of the calendar it is. The day of year, which day of the year it is. The week, which week number it is. The last day, we want to know how many days are in that month. The day name, okay, is going to give us the name of the day. The month name is going to give us the month name. Okay, what if we have a what if we have a date time column? Um, how can we extract these things? Well, we can say we can use the function extract, and then we say unit from date. So extract second from the field. So second will give you seconds, minute, minutes, hour, hours, day, day, month, month, year, year. Okay. Now we can only extract the time parts if this is a date type that includes a time part. Here's some more things that we can ask for: minute, seconds, hour, minute, day, hour, year, month, hour, second, day, minute, day, second. And here's a lot of examples. Okay. And I'm just going to let you read through them all. I think they all behave pretty much as you would expect. We've got two functions for formatting dates and times. We've got date format and time format. Okay. So we need to give it a for the date format, we need the first argument to contain a date. In the time format, we need this the first argument to contain a time. And then we're going to have a format string, okay? And that format string is going to have these meta characters that we see in the table, and they're going to give us the results that we see over under description. And here's some more format strings. And here are some examples of what we can do. So again, I'm not going to read all the examples here. They're a little too detailed, but you can see that with a little care, we can get dates and times behaving just as we would like. There are times when we want to do date arithmetic. Okay? So we have a date add, we have a date sub, we have a date diff, we have a 2 days, and we have a time to sec. So let's go explore those a bit. So we're using date add, so we have a fixed day, and we're adding 1 day. So we say interval 1 day. Here we say interval 3 months. We can say date add interval 1 second. We can say date add interval minus 1 day. That's going to subtract a day. We can say date sub interval 1 day. That's going to do the same thing as date adding a negative 1 day. Date add 1 year. Okay. Date add 1 year is smart enough to know that if we're on the 29th of February, it's going to say a year from now is the last day of February, if that's not a leap year as well, which it wouldn't be. Okay. I'm sorry. These two things are okay. Never mind. I get it. So the first of these ones, the one we're saying, what's a year after 2/29/2011? It is 2/28/2012. And if we say what's a year after 2/29/2012, the reason we get a null is that there is no 2/29/2012. So that's an error response. Okay. We can date add with a day hour. We can date diff. So here are two different dates. It's going to give us the difference in days. We can date a diff when we're in and include a time. We can date a diff and not include a time. And we can have it be negative days. Uh, we can we can say that we have a certain date, and from this date down here, how many days to the I'm sorry, that's wrong. So we're taking 2 days, which is going to convert this to the days in the year, and we're subtracting the other 2 days. So that's how we can tell that there's a difference of 27. And the time to sec is going to give us 60. Okay, so we can have some problems with dates or date time combinations that are not going to give us the result that we want in a query. Okay, so here's a date sample table. Okay, the first 3 rows have times of all zeros for the time. And we can say select all rows from date sample where start date is equal to 2014-02-28. Okay, so we're not trying to match on any time. And because we're not trying to match on any time, we get a match on nothing. Well, perhaps that's not what we meant. Okay. So there are 3 techniques for ignoring time values in this kind of query. Okay. We can have a start date and say greater than equal the beginning of the day and less than the next day. Okay. We can search for month, day, and year integers. So we could say where the month of the start date is 2 and the day of the month is 28 and the year is 2014. Okay. Or we could search for a formatted date. And this is a very popular one that you'll see people do quite a bit. Okay, so they'll take the date, they'll format it to just month, day, year, and they'll compare it to a string. Okay, pretty interesting. Here we have contents of a date sample table again. And now we're trying to match a row based upon time. Okay. And we're saying the start date is 10 o'clock, but we're not saying 10 o'clock on any particular days. We do have a 10 o'clock in row 4 on 228, but that's not giving us a match. Okay, how could we fix this? Well, we could use the same trick that we just used with the date fields, where we compare a formatted date and pick just the time and compare it to the time that we want. Okay. Search for a time that hasn't been formatted. So we could say where extract our second from start date equals this. This is going to get us the same thing. Okay. What's better documentation? I don't know. I kind of like the formatted one myself, but they'll both work. Um, Examples that ignore date values. So what if you wanted to what if you wanted to consider the time but not consider the date? Okay, uh, things that happen in the morning, for instance, or things that happen in the 9 o'clock hour. Okay, so here the first one we're using the function hour of the start date equal 9. Okay, so we can't compare to the whole start date, but we can pull the hour out of it with the hour function. Okay, or we could say extract our minute from start date between 900 and 1200. Okay, that sounds pretty doable too. Okay, so now we're going to work on the case functions, and I have to say that these take some care, but they what I call pretty cool. So, we had this kind of use case before, and you remember that when we were trying to figure out some uses for the union operator in the select, we had some situations where we were classifying each row. Well, we can use this case expression as a way to classify things. So here on slide number 38, you can see that we say that we want case of terms ID, and then we say how to translate the terms ID. So when one, then net do 10 days, when two, then net do 20 days, etc. Now, I think I just want to point out that you only want to do this if you don't have a terms table. Okay? Because if you have a terms table, you should have these things in the table, and you should be able to get the same information with a proper join. Okay? You just would have to join the invoice table with the terms table. So I don't approve this as a way of overriding the terms table, but I do approve this as a way to classify things and get the kind of text that you want into the column instead of the base values. And then we have a search case function. Okay, so let's look at how that works. It's a little bit more expressive. So we have a case, and we say when dateDiff now, comma invoice due date, when that's greater than 30, okay, then over 30 days past due. When dateDiff now is greater than 0, then 1 to 30 days past due, else current. Okay, so this is like an else if, right? So we say when, and it does the test, and it's a pretty expressive test. We're just not able to check one value, but we can have a pretty elaborate expression. So we have when, all the whens are like if, else if, else if, else if, and then the last one is just an else. Okay? That is really expressive. The if, let's look at the if. uh, so we say if, and we have a test expression, and then we have two more expressions that come afterwards. Okay, so the the first expression is the test. The second expression is the value to use if true. The third expression is the value to use if false. So select vendor name, and then we say if city equals Fresno, yes, otherwise no. So if we're getting, so we're going to get yeses for a situation where the vendor city is Fresno, and no for all the others. We can also check if null. Okay, so we can say, we can do the same thing. So we can say if null, and there's a test expression, and then we can have a replacement value if it's null. So select payment date. If null payment date, then it's no payment. So this is a way, when you look at the answer set here, we can see that it's a way to populate the column when it otherwise would just be null. There is a more expressive version of this called coalesce, in which you have a series of expressions, and it continues down the series of expressions until it gets one that's not null. So I really like this one the best. So we have coalesce payment date. So if a payment date is not null, then it will use payment date. If it is, then it goes on to the next one. Now this one is never going to be null because it's just a string, so it says no payment. But you can have a series of things. You can have 3 or 4 or 5, so it can be pretty darn expressive. So in this instance, the if null on the prior slide and the coalesce on the current slide did the same thing, but the coalesce is a more expressive kind of statement because it can give, so you can have the primary source, then you can have the first backup, then you can have the second backup, then you can have the third backup, and then only if all those were null would you choose the ultimate backup, which would be some kind of character string or some kind of a number. So it's, as I said, it's pretty powerful, pretty expressive. Okay, so I'm not going to do a tutorial demo for this particular chapter, largely because it's just a matter of kind of sweat equity to get these. Okay, so I'm going to give you two options. One is you can just go right on and do the exercises from my guitar shop. The other one that I would recommend is to look at the exercises from the chapter in the book. So go to the end of chapter 9 and look at the exercises there, and then review the solutions that came for those exercises in the book, and I think you get a pretty good idea about how to approach these things. It's going to help you when you go to do the My Guitar Shop exercises yourself. So good luck with all that, and I'm going to say bye until next time. Bye-bye.